Good morning, good afternoon, good evening, drone pilots, wherever you are, whenever you are. The goal of today's video is to connect our drone to Mission Planner through the Express ELRS radio. So using Mavlink, and here is a image of what our goal is today. So we have our drone in the air, and it's already connected to the radio controller with Express ELRS, which you should have done already. And what we want to do is then use the radio in its Wi-Fi as a Wi-Fi hotspot to connect to Mission Planner and pass through Mavlink traffic all the way from the drone to Mission Planner and vice versa, so you can have a computer connection to your drone. And because Express ELRS is long range, up to tens of kilometers or more, you can easily connect to your drone in the air, whereas Wi-Fi is limited to about 100 meters or less. The bad news is it's very slow. The bit rate is low, but the good news is it's long range. So that's the goal. So as usual, we have a detailed instruction file called Telemetry with Express ELRS. And that's the video we're going to go through. I have an abbreviated instruction file. If you have already done this and you just want to change something or remind yourself, where it tells you what you need to do. So basically, we're going to have to adjust things in Mission Planner for ArduPilot. We're going to have to adjust things on the radio transmitter, and we're going to have to adjust things on the radio receiver. So that's what we're going to go through in detail now with these detailed configuration instructions. So as a prerequisite, you should already have your drone. You should have your radio receiver connected to your drone flight controller. You should have it working using the standard method that we covered in tutorials 1 through 5 on this website under Burke Aviation YouTube playlist. So we should have flashed the flight controller. You should have radio 1, 2, 3, 4, 5 done, and also ideally Wi-Fi telemetry done. And once you've done that, then we're good to go. The reason is we're assuming you already have Mission Planner installed and most of the firmware installed for the radio connection. And we're assuming that you understand what Mavlink is, which was covered in the Wi-Fi drone bridge tutorial. So here are the 3 pieces of hardware we're going to be working on today. One is the flight controller, which is the brain of your drone. One is the receiver, which is the radio receiver on your drone. This little square thing receives the LoRa signal. But because it's a ESP32 chip, it also has an onboard Wi-Fi capability, which is not shown in this figure. And then the third piece of hardware we're going to be using is the radio transmitter, which with this big antenna sends the radio waves to your drone. But internally, there's a radio module that also has a Wi-Fi hotspot possibility internally. So that's how we're going to be. That's the hardware we're going to be doing. So for the wiring of the flight controller to the radio, the bottom is a picture of the Express ELRS radio, and the top is a schematic of the flight controller. So you should have already wired this, but this is just to remind you, you're wiring up the power to the flight controller, obviously, but you're also sending signals from the radio that receives it from the ground to the flight controller, telling your drone where to go. Go up, go down, go left, go right, etc. And those are sent with only one of these wires. However, we're going to be sending information back down to the ground, so we want both wires connected, which I'll explain here in a few minutes. So this is the wiring that you should have already done. Now, for both of them, let's see, where did that go? So for both possible systems, the old-fashioned Crossfire or the new Mavlink, it should be wired up like this. And for both systems, we need to change some things on ArduPilot, okay? So the first thing is, it says RX2 and TX2 on the physical board. However, usually this board was made before Express ELRS was common, and usually we just used port 2 to receive a radio signal. We were never sending information back down to the ground. So the way the flight controller was configured and built and connected with all the different internal options for the STM microcontroller, it's not going to work. Long story short, it's not going to work. If you want the details, here's a link to it. But basically, we want to be able to send information back and forth. We want a two-way flow of information, and serial 2 internally on the microcontroller isn't going to work. We're still wiring it up to the pins labeled RX2 and TX2. However, internally, we're going to divert that to serial 6. So we have to configure board alt config 1 to serial 6. And that means we have an alternate board configuration. So let's go ahead and power things up and get that going. So I have a camera here, and this is showing the radio controller. So let me go ahead and turn that on.
Hey Peter, welcome back. Disarmed. Stabilize mode.
Okay, so that's the radio. We'll put that back in a minute. There's the drone. And I'm going to, right now, there's nothing plugged in to the computer. So now I'm going to plug the drone in. No, there's no props.
Telemetry connected.
And now I'm going to take this USB cable and plug it into the computer. And you hear the computer beep. And if we go to Device Manager, it'll show us that we have COM port 5. If I disconnect the flight controller, COM port 5 goes away. There's no COM port. So I connect the flight controller with the USB cable, COM port 5. Now, so I want to go to ArduPilot. According to the directions. Here, I want to go to ArduPilot and change this parameter. So I go to Mission Planner. And we're going to use COM 5. I'm going to use 900 kilobaud because that's fast. And that seems to work with my USB.
Mode change to stabilize.
And I need to go to the... Okay, so let's wiggle the drone. So you can see I'm wiggling the drone and the flight controller is responding. So we're connected. So I want to go to Configure, Full Parameter List. And I need to change this one called board BRD underscore alt underscore config. So over here I'm going to search for BRD underscore alt underscore config. So that's set to 1, which is fine. If I were to change it, let's say I made it 0, then I'd have to write the parameters to the drone. And I wouldn't like that. It says reboot is required. So I'm going to set it back to 1, write the parameters to the drone, and now it's back to 1 where it should be. Reboot is required. So if I press Control F for the secret menu, and in one here is called Reboot Pixhawk, I can reboot that. And now it's disconnected. It's
Mode
rebooted.
change to stabilize. OSD failed to load font 1.
Okay. So that's that one. Board alt config is 1. The other thing we want is RC protocols is 1. So I can search RC underscore protocols. It's already 1, so we're done. So both of those ArduPilot settings are common to both these methods. The board alt config, because we're diverting internally the pins that are labeled as 2 to the internal software called serial 6. And we're also telling the flight controller that no matter what the protocol is, whether it's PPM, S-Bus, F-port, Crossfire, etc., that it'll interpret them and automatically configure itself internally depending on what we use. Okay, now the next step is option 1, Crossfire protocol. So if you switch it to Mavlink, this is how you get back to Crossfire. You should already have it on Crossfire. So, but this is how you go back. So what is Crossfire? What is Crossfire? Crossfire is a protocol that was invented by a company called Team Black Sheep. Team Black Sheep is a company that make serious toys. They make all sorts of radios, transmitters, and receivers that you can use for your drone. They were the first company to use the LoRa protocol, which is a long-range, low bitrate protocol. We'll discuss that in lecture. And that's what enables 100-kilometer range control of drones. Now, it's an outstanding product, and but the software, the firmware they use is proprietary, and the hardware is proprietary. So that's what TBS is. And Crossfire is the name of the protocol they use. Now, Express LRS is an open source version that has open source firmware using this LoRa and open source hardware from all these different companies. We're using Happy Model, but it's open source. You can clone it and make your own. You have your own made if you want. All the hardware and software is open source, but it still uses the Crossfire protocol. So both TBS, the company, and ELRS, the open source movement, use Crossfire as a protocol. And so we're going to use Crossfire, which we already configure, but now I'm just being more specific. Now, Crossfire is bidirectional. It means the protocol can send information in both directions. However, ArduPilot does not really support much with Crossfire downlink from the drone to the ground. What it does support is if your radio is disconnected. So I'm going to show you what happens if I disconnect the radio. Let's go to the camera here. So there's the drone. Now let me disconnect it from Mission Planner. Disconnect, quit Mission Planner. So I can actually unplug it just for your convenience. And I have this battery here. And now let me put the radio here. So here's the radio, and it's actually got those three little bars showing how good the connection is. Now if I unplug the drone and turn it off, the drone turns off.
Telemetry lost.
And the radio immediately says telemetry lost. So that is a communication between the transmit radio and the receive radio, not the flight controller, but the receive radio. That's very, very useful. So if you ever hear telemetry lost, you should get nervous, because that means you've lost connection to your drone. So if that happens, you need to have failsafe configured so your drone will auto-land on loss of radio connection, because we don't want any flyaways. Okay, so that's Crossfire, and that's what we're going to be using now, which is the old-fashioned way. So here are the ArduPilot settings.
Incoming voice call from...
So in the interest of time, I'm not going to keep showing the drone every time I plug it in and unplug it. But the drone is on. And now I'm going to plug it into the computer. And these are the settings I need for Crossfire. And we'll go to Mission Planner and connect.
Mode change to stabilize.
So I need to configure, since we're doing Crossfire, no, I'm not planning, I need to configure serial 6. Remember, serial 6 is actually pins labeled 2 and RX2 and TX2, but we rerouted it to serial 6. So I want the baud to be 460,000, no options, and then the protocol, that needs to be RC in. Okay, then I need to write those parameters. Yes. Okay, and then we won't reboot it yet. And the other thing I have to do is set the RSSI type to 3. Now, we can just search here for RSSI type. So we have to select all. And then here's RSSI type. That needs to be 3. Receiver protocol, right parameters. Okay. So, that is what I needed to do in order to have the RSSI, which is the received signal strength indicator, show up in the flight controller. And it also shows up on the OSD if you have it programmed correctly. Here it's shown as 100%, meaning I have a good link. That's the percentage link quality between the radio in the air and the radio on the ground. So you can monitor that in real time to see if it's getting bad before you have a complete disconnect. So I have to do that, and then of course I have to reboot Mission Planner. Okay, so that's
Mode change to
what I have to
stabilize.
do. And then there's more.
OSD failed to
I
load
also
font
have to
1.
change the settings on the transmitter. So here's the transmitter, and I have to run the Express LRS Lua script. So press System, and then right-click the roller to get into that thing, that script, and then scroll down here to Link Mode, right-click, down-click the roller, change that to normal, down-click it. Error, not well connected. Okay. That's fair. So let's disconnect and quit Mission Planner, and unplug the drone from the computer, unplug the drone from the radio,
Telemetry lost.
and now it should let me normal. Okay, so then I can scroll down to the bottom and say exit, and then hit return. And just for good measure, I'm going to cycle the power on the radio.
Hey Peter, welcome back.
So,
Model warning.
oh yeah.
Disarmed. Stabilize mode.
So the instructions for getting Crossfire to work were to set the link mode to normal. So we did that. And then there's one more thing we need to do. Okay, so now I need to change the receiver. So I'm going to turn this off again and put that to the side. And now the drone, let's unplug that. The drone is now connected to nothing. And I have mine configured so that the Express LRS receiver is right there on the bottom, so the antenna is pointing down. So now let me plug it in. The radio is off. Okay. So the radio is off, and now that's green light on the receiver is blinking. That means it's trying to make a connection to the radio, but it's not going to work because the radio is off. So if we wait 30 seconds, or 60 seconds, that green flashing light will blink fast. When it blinks fast, there's a hotspot. I put XXX here. It's going to be the Express LRS hotspot. And then we need to connect to that hotspot, and that will allow us to log in directly to this radio receiver. It's got its own website on it. It's really amazing. It's 0.5 gram. It's the size of my thumb, and it can create its own hotspot. So we're going to wait for that. Let's see if any are coming up here. Not yet. So we have to wait for it. And when it comes up, we go to 10.0.0.1, and we'll change the protocol to Crossfire, and then we'll be done with this configuration of doing it the old-fashioned way with Crossfire. Now it's blinking fast. That means it didn't bind to the radio. So if it can't find the radio, then it creates a hotspot so you can configure it. So we go to the Wi-Fi and connect to the hotspot called Express LRS RX. The password is Express LRS. And Windows won't like it because it doesn't connect to the internet, but it'll work for connecting to the hotspot, which is going to be 10.0.0.1. So there it is. And it was Mavlink, so I want to make it Crossfire. And I want to click Save. Set configuration updated. Okay. So hopefully that is all we're going to need to do for that option. And now, of course, I'm going to unplug the drone. And then let's turn the radio on. And then let's turn the drone back on.
Disarmed. Stabilize mode.
And let's plug the drone into the computer.
Telemetry connected.
So that means they're connected to each other. Now let's plug the drone into the computer. So the drone's plugged into the computer. I have to. Okay, let's just confirm that. And now I want to connect at 900. So this is going to be over the USB port.
Mode change to stabilize.
And it's very quick. And now let's see if the radio is working. If I try to change the mode of the radio,
Mode change to loiter.
changes. Okay.
Mode change to
I try to
RTL.
arm it, it'll arm
Mode
it.
change to loiter.
And,
Mode change to stabilize.
I can go to setup,
Armed.
inventory hardware,
Disarmed.
radio calibration. As I wiggle the sticks, things are happening as I wiggle the sticks. Okay, so that's the way. If you ever have it in Mavlink, you want to go back to the old-fashioned method of Crossfire. That's how to make it work. Okay, and just to remind you, there is a abbreviated instructions here that shows you, how you go to Crossfire if that's what you want to do. Page level. Okay, so all we did was configure these RGPilot settings, configure these RGPilot settings, made the link mode normal on the radio, and made on the receiver with the website the serial mode Crossfire. Okay, now the next step is going to be what is more interesting, which is this method here, where we're actually going to use the ELRS radio to pass Mavlink traffic. So we're not going to be using Crossfire as a protocol anymore to communicate up and down between the drone and the radio. We're going to be using Mavlink. So that's a little bit more involved. And what we have to do is we're going to have to actually install some firmware in the radio here, which I'll walk you through, and then configure everything correctly. So we have to configure the drone flight controller. We have to configure the radio on the drone. We have receiver. We have to configure the radio transmitter, just like before. So here's the steps that we have to do. So RGPilot, first of all, we need to change the RGPilot. So we need to change the serial 6 protocol to Mavlink. It was Crossfire, and we need to change the RSSI type to 5. So we're connected to the drone, and in the interest of expediency, since we just did this before, I'll make the RSSI type 5. That's telemetry radio. Write that to the drone, yes. And then the serial 6 protocol. We don't want to search because there's nothing in there. So serial 6 protocol, instead of RCN, it's going to be Mavlink 2, which is number 2. Write that to the drone. Yes. Okay. So I have to reboot it. So, okay, let's reboot it. Reboot. All right.
Mode change to stabilize.
So that's pretty straightforward.
OSD. Failed to load
We
font
just told
1.
RGPilot to look for Mavlink traffic instead of Crossfire traffic from the radio. Now on the receiver, we need to go back to the receiver and tell it to pass Mavlink traffic that it gets. Once the receiver gets the traffic, we want it to send it as Mavlink to the drone. So again, we have to log on to the website of the receiver, which means we have to have everything disconnected from the drone. The radio has to be off. Radio's off. Okay, turn the drone on and wait for the receiver to flash rapidly, and then we can log into the receiver and we'll change its protocol to Mavlink. So that will take a moment. So we just have to wait until the receiver flashes. Okay, it's flashing fast. Now we can log on to it. Express LRS RX, that's the receiver. So we're going to log into the website of that receiver. Then we're going to go to 10.0.0.1. We logged onto the receiver. We want the protocol that it sends to the flight controller to Mavlink, and we press save. Configuration updated. Great. All right, what's next? The next part is the hard part, which is the firmware we have to flash to the radio transmitter. So let's unplug the drone, get that out of the way, and let's look at the transmitter. So here's the transmitter. I'm going to go ahead and turn it on.
Hey Peter, welcome back.
Okay. Now,
Sorry.
inside of the transmitter, in the back, you can actually see that red light flashing. That is the a Wi-Fi chip. It's got an ESP32 in there and a LoRa, and they're what constitutes the Express LRS radio inside of this shell. And we need to flash to the Express LRS radio this thing called a backpack. And what is the backpack? Let's see. If we go back to the image of what we're trying to do, the backpack is inside of this Radio Master is the Wi-Fi chip it's ESP Wi-Fi hardware that's going to allow us to log into that from the computer over Wi-Fi. So it's going to make a hotspot out of the internal radio inside of the Radio Master transmitter. So it's called a backpack. So we have to flash some new firmware to that. So we have to power it up, which we did. Now we have to connect to the computer. We have to connect the radio to the computer. So we're connecting it to the computer. Now we want to do serial, and that'll pass the traffic through from the main part of this radio all the way deep inside of the Express LRS radio inside, which is what we want to mess with. So now we need to run Express LRS configurator and then flash the backpack. So here's Express LRS configurator. We want backpack. We're going to have version 151 target. This is all listed in the instructions. The target's going to be Radio Master. The device is going to be Radio Master Pocket 2.4 gigahertz TX. We're going to do pass-through, so it goes through Edge TX deep into the radio. I'm going to leave the binding phrase alone. We're not going to do anything with the Wi-Fi. And I have to use this COM port, which came up when I connected it. And we're not going to erase before flash or force flash. I found that's not needed. And now we want to flash this in. So flash it, hold your breath, cross your fingers, and it will download and compile the backpack firmware and then hopefully flash it to the board. Okay, it's doing that. It's writing it. And we're done. So we've now successfully flashed the backpack to the Radio Master Pocket internals. Okay. So now we need to go back to the radio here. So it's flashed now. So I'm going to disconnect it from the computer. Just for good measure, let's go ahead and power cycle it.
Hey Peter, welcome back.
And there's only a couple settings we need to do to tell it to work. So I need to go to System Menu, run the Express LRS script, and I need to scroll down here to link mode. So the link mode now is going to be Mavlink. Okay, that's one thing. And the next thing is we have this submenu here called Backpack. So the flashing worked. and we can configure the backpack by clicking on that. Backpack on. Yes, we want it on. And then the telemetry will go through Wi-Fi. And that's configured. It could be Wi-Fi, ESP now, or off. So we want Wi-Fi. We want the backpack. Could be off. We want it on. And then we go back and exit and return. Now, again, just for good measure, I'm going to power cycle it. Okay.
Hey, Peter, welcome
Now,
back. Disarmed. Stabilize mode.
now it should all be working. So that is the end of the directions for how to configure things. Now let's go back into Mission Planner and test it. So what I'm going to do is put the radio is still on. We'll put it to the side for the moment. We'll go ahead and power the drone on. And hopefully it will
Telemetry
connect to the radio.
connected.
Yeah, there we go. So it's connected to the radio now. And then I'm also going to look at Mission Planner to make sure the radio is coming in the way it should. So let's connect. Now I'm going to connect with a USB cable to Mission Planner for the this initial configuration phase, just to make sure things are working. So we go to Mission Planner with the cable, and okay, so we're going to go through COM5. I'm going to use 900 kilobaud and connect. So this is connecting to the flight controller with
Mode
USB
change
cable.
to stabilize.
And if I wiggle the drone, that wiggles. If I change the mode with the
Mode change to
radio, it
loiter.
changes.
Mode change to RTL.
I can arm it,
Mode change to loiter.
and then
Mode change to
let's look at
stabilize.
the inputs here.
Armed.
So if I wiggle
Disarmed.
the sticks, the inputs are all working. So that's good. That means that the flight controller is getting the radio signals. The radio control still works fine. So what's really fascinating, let's disconnect this now, is we don't want the cable, right? So let's go back to the camera. And this is the radio. We'll put that to the side. Here's the drone. And I'm going to unplug the USB. And there's the drone. It's not connected to anything. Okay? And the radio is going to have its own Wi-Fi hotspot called Express ELRS Backpack. So I can connect to that Wi-Fi hotspot, and that's in this radio. Okay, so the radio is controlling the drone.
Return to home.
I can
Stabilize
arm the drone. I can throttle up.
Disarmed.
I could fly it now if it had props on. But the drone is not connected to any wires. But the drone and the radio are connected through Express ELRS. And now that this radio has a hotspot, which is Express ELRS Backpack. So I connect to that.
Mode change to stabilize.
And Bob's your uncle now. It's connecting to Mission Planner. Now the bad news is it's a very slow connection. So you have to download all these parameters, and it's not too bad. But you'll notice if I use the USB cable, it downloads it in a minute, like in a second. Now if I use the drone bridge, it downloads in about 5 seconds. But with this Mavlink, it's very slow. It's a low bitrate, long-range protocol. So it's going to take a minute or two to upload. So let's give that, or download. So let's give that a minute, and then we'll be good to go. Okay, so it takes a while. There's the drone. Let's do this. Let's show it like that. Now if I move the drone, the artificial horizon changes. But you can see it's kind of slow to change. So this is a long-range protocol, but it's got about a second of lag, so you don't want to use it for things that are really time-sensitive. But if you just want to plot the position of your drone on your map or start a waypoint mission or change its mode, this is a great way to monitor what the drone is doing in the air. So my advice is to use this in the air, but when you're on the ground, use the USB cable or use Drone Bridge, which was covered in a different video. Happy flying!